Hello everyone. So here I have a question with me, and this question was asked in the JEE Advanced 2023, one of the hardest exams in India. So let's go through the question. So a bar of mass m is equal to 1 kg and length is L is equal to 0.2 meters. So let's make this into a diagram. A bar of mass m. So let this be the bar. What on the bar is pivoted at a point. So here is the pivot, about which it is free to rotate. Okay. So this is the length of the bar, L. The mass is M. I'm not putting in the values right now. First, I'll solve this question in terms of M, L, and the other variables. And afterwards, I'll put the values. So a small mass M, small m, is equal to 0.1 kg, is moving in the same horizontal surface. So this bar is lying on some surface, and on that surface, another particle of mass small m is moving horizontally towards the bar on a path perpendicular to the bar. So the bar is lying like this, so the particle is going like this. So they're perpendicular, 90 degrees to each other. It hits the bar at a distance L by 2 from the pivoted end. So here is the pivoted end, and from this end, it is hitting at a distance L by 2. So it hits here. And returns back on the same path with speed v. So what happens is this particle comes here with some speed, with this speed, 5.00 meter per second. So let's call the speed u. And once it hits this bar, it comes back with a speed v. After this elastic collision, the bar rotates with an angular velocity omega, and the bar rotates with an angular velocity omega. Which of the following statement is correct? So we essentially have to find the values of v and omega. Okay, so this may look like an overwhelming question, but hear me out. We just have to use two basic principles: conservation of angular momentum. Now, angular momentum is one of the quantities in physics which remains conserved. Now, angular momentum remains conserved of a system if there is no external torque acting on the system. Now, if we take the system as the bar and the particle combined, then there is no external force which is producing a torque on the system, which means that we can apply the law of conservation of angular momentum here. Okay, so the law of conservation of angular momentum says that the initial angular momentum, Li, would be equal to the final angular momentum, which is Lf. It will remain constant. So the initial angular momentum, the bar is not rotating. The only thing which is moving is this particle, which is going in this direction. And let us consider the angular momentum from this point, as it is the easiest one to consider, because there is no force acting there, and there is no velocity at that point, because the point is pivoted. So with respect to that point, the angular momentum is m, which is the mass of this, times the velocity, which is u, times the distance between the velocity and the point, which is L by 2, equals the final momentum. Now, when the particle has already hit the bar, there will be two things. This particle will return back with a velocity v, and also this bar will start rotating. Now, due to the rotation of the bar, it will have its angular momentum equal to I times omega, where I is the moment of inertia of this bar. The moment of inertia of a bar pivoted at one end is m times L squared by 3 into omega. And then we write the angular momentum of this particle. Now this particle is moving in the opposite direction, so we subtract the angular momentum, which is m times v this time, because the final velocity is v, and the distance remains the same from the point, which is L by 2. Now we have got the equation of angular momentum. we have two unknowns, which is v and omega, and we only have one equation, which means we also have to find another equation. Now that equation is the coefficient of restitution. Now, it is given in the question that this collision is an elastic collision. Here, what it means that there is no loss of kinetic energy. So, the coefficient of restitution given by E, it is given by velocity of separation upon the velocity of approach. So, what is the velocity of separation? Which means, what is the velocity by which the bar and the particle are being separated? So, the particle has a velocity of v, but this point of the bar also has some velocity. The velocity of this point of the bar is omega times L by 2. That is a linear velocity, which is omega, which is the angular velocity, times the distance of this point from the pivot, which is omega times L by 2. So that is the velocity of that point of the bar. So velocity of separation is omega L by 2, and v in this direction. Now, it doesn't mean that this point moves in this direction and the particle moves in this direction, so we need to cancel out the velocities. No. Well, we are speaking about the velocity of separation, which means how fast are the bodies separating. So if this velocity is more and this velocity is more, the two bodies will be separated more faster. So which means that we need to add these velocities. We can also think in terms of relative velocity. The relative velocity of this point with respect to this particle would be v plus omega L by 2. So omega L by 2 plus v, bond velocity of approach. Now in the initial condition, the bar is not rotating. There's only this particle which is moving towards the bar. So the initial velocity of approach is just u. Now this coefficient of restitution, this is 1 for elastic collisions. Now we take this here and we get another equation. Let's put v is equal to u minus omega L by 2 in this equation, this one. So let me substitute it here. We got MUL by 2 is equal to ML squared 3 times omega minus M. Now V is this, so U minus omega L by 2 times L by 2. Have I written incorrectly? Yes, I have. Okay. Now it is just an equation. We need to solve the equation. Let's divide the whole equation by L because we have a lot of L's here. You don't need a lot of L's. So mu plus m omega L by 4. I'll multiply this. Here. Okay. So there it goes. This L is cancelled here. Yep, cancelled all the L's. Forgot that. Yeah. So this moves here. We've got mu is equal to ml omega by 3 plus m omega L by 4. Which means mu is equal to, we need to find omega. Omega is the unknown here. Omega times 4ml plus 3ml, small ml, whole upon 12. You got the value of omega as 12 mu upon 4 ml plus 3 small ml. We can factor out L in this expression, and it gives us this as the final expression for omega. Now we just need to plug in the values. So our values given in the question, small m is 0.1. So let me note it down here somewhere. Our small m is 0.1. Not writing the units now. U was 5, I guess. L was, I guess, 1 meter. 0.2 meter. I don't remember. 0.2, okay. So it's 0.2. The capital M was 1 kg, I believe. Yes, it was, okay. There we go. Now we just need to plug in the values. Is equal to 12 times small m is 0.1, u is 5, L is 0.2, 4 times M, what just before, plus 0.3. We cancel these points out. 6, we get this. 6 times 5 is 30. We get this is 4.3. We can reduce this to 300 by 43. 43 by 300. Let's try to divide this by 6. 6 times 4 is 240. 240 times 6 times 40 is 240, and 3 times 6 is 18. 240 plus 18 is 258. Then we subtract 420. So 43, let's try 9. So 40 times 9 is 360. 360 plus 3 times 9, 27, is 387. So minus 387. That gives us 3 here. And let's try 8 maybe. So 4 times 8 is 320, and 3 times 8 is 24. So yeah, approximately it is 6.7 something, or we can approximate it to 6.98 if we want to approximate it to 2 decimal places. And let's check if our answer matches one of the options. So yes, it does indeed match with this option. So we have just found out the value of omega, which comes out to be 6.98 radian per second. We can also find the value of v from value of omega by using this equation we got here. We know u, we now know omega, we can just calculate v. And that's how we solve questions like this. So what I was trying to show here is physics is not tough if you understand the concepts correctly and apply them at the right places. We've just used 2 basic things here: the conservation of angular momentum and the coefficient of restitution, nothing else. And still, this question, only around 0.2% people are able to solve this. So yeah, see ya.